So guys, I'm back with another video. I would like to talk about my consistency. I'll get straight into the problem. So today we're going to try minimum path sum, another DB problem today. As you can see the problem tags here. Uh, the related topics here are dynamic programming, matrix, and array. So these are the related problems. So this is asked in Microsoft internship uh, interviews. So the question here, let's try to understand the question first. So there's an m into n grid, so it's a matrix. So it's filled with non-negative numbers. We need to find a path from top left to bottom right, such that we get the lowest sum. So this is kind of similar to a rat in a maze problem in which we use backtracking concept. So except here is that we're going to use the backtracking concept along with the memoization to make it a DB problem. So as you can see, let's see the first test case. So 131, 151, and 421. So here we have to go from this point exactly here. Let me show. So here to here we have to go. So we have each time we have a choice. Each time we can go down or we can go to the right. So here at position number 1 we have two options. We can go to 3 or we can go to 1. And then if we go to position number 3 we have two choices. We can go to 1 or 5, but there are many edge cases such that, for example, we are in the rightmost point, we can't go right, but we can go down. Or we are at the last row, then we can't go down, we can only go right. So such situations we have to take care of them separately. So we would go towards the backward way of going in recursion. So we would start from the last element. I'll try explaining the problem now. I hope you guys understand it. So you guys can see the matrix here exactly. Let me zoom out. Yeah, so you can see here there's a matrix 131, 151, 421. Here if we can't use greedy approach because I let me show you what will happen if you use greedy approach. Imagine you're at 0 comma 0 position here. Imagine you're at 0 comma 0 position here, and then you move to the right because you move down because 1 is lower. After moving here you have two options, 5 and 4. 4 is lower, so you move here, and then after moving to 4 till now your sum is going to be 4, 5 and 6, and then afterwards you have only one option to go right, and then you go right, you get 1 plus 1 which is 2, and 6 plus 2 which is 8, and then you go right, you get a value of 9. So here 9 is here 9 is not the shortest one with the minimum path sum. We have one more route, so this would be 13111. So this is the best way to do this is through dynamic programming. First we'll try the recursive calls one by one. So imagine we'll go from last to first. That's what our approach was. I'll try explaining the recursion tree properly. Hope it makes sense now to you people. So left side of the recursion tree would be to go left. We are starting from 2 comma 2, right? We have to go to 0 comma 0. So each time we have two options, either to go left or to go to the top. So imagine you are at 2 comma 2 here. You are at 2 comma 2. So at right now your value is going to be 1. Okay, so you have two options. You can go to 2 comma 2, 2 comma 1, and then 1 comma 2. You can go to 1 comma 2, which is top, and then you can go to 2 comma 1, which is left. So on it will go on up till you reach the point 0 comma 0, and your 0 comma 0 would return the value which is presented, which is equal to 1. So each time you would choose the minimum of left and right of the trees, and you would go on to the top. So I suggest you people draw your recursion trees. You get it. See, f of 0 comma 0 is equal to 1, so that value would be returned. So let us try coding it up now. First we'll get the recursive solution, then slowly we'll approach it by memoization. So first we'll try defining our helper function. A helper function would return a int value, and then it would have a value such as the grid itself, because we need the grid values, and then we would need the row value, and then we need the column value, and then what else? Yeah, that's it for now. And then we'll write a base case. As I told you people, the base case would be when you reach this point, you would just return this value, 1, which is present there. So if row is equal to 0 and the column value equal to 0, then we would return the grid values directly. No problem. Okay, we've written this. And then I was telling about two edge cases which we need to take care of. Like for example, if it's in the leftmost point, imagine you are at this point here. Let me show. Imagine you are at 1 comma 2 here exactly. You can you can go left and top, but if at all there's a case where imagine you're at 0 comma 2, you can't go up. So that should be handled separately. And imagine you're at 4 here exactly here. So then you can't go left. So those will be handled separately. So we'll write a function for that. I mean, we'll write if condition for that. If at all row is equal to 0 and the column is not equal to 0, then what would we do? And then if at all the column value is equal to 0 but the row value is not equal to 0, and then by default what would we do? So that would be our last condition. So here we would just return the grid value of row and then column plus, now we'll do the recursion call here. It will be the helper, it will have the grid value, and then it will have we are going to the left, so we can't go left, so we keep row as it is. And then now we take the column -1, so we would go to the top. So that's what we're doing. Sorry, this is going to the left. And then our next case also would be similar to this. I'll just copy this. Grid, row and column. Yeah, we'll do row -1 and then column would be as it is, no problem. And then by default our case would be if at all it's in, if it's not in the edge, like topmost or leftmost, then what we'll do. So we would just return we would return the help, we would return the grid value plus grid value is always there, we would always add that, plus the min values of these two. Let me take this and that, and even this value of both these recursion calls. I would take both of them. We have these values, we will just return these values with no problem. So far I hope you guys understood what's going on here. It's all on the recursion tree. Each branch is one recursion call. So now we'll try using this recursive function. Let's check whether it's going to work out or no. So let's first check what all arguments are functions taking, and let's define them each. So grid is anyway there, but we are starting from grid of length -1 because that's the point, that is the rightmost point. Here you can see the grid length, the grid rows and columns are same here, but the question defines that it's not the same. Like sometimes it may be different. So here you can see it's 3 into 3 matrix. So we need to start from 2 comma 2. So grid 0 dot length -1. We start from there. That's it. Let's check whether our function is working or no. Yeah, you can see it got accepted. Now I'll try submitting. We must get a TLE. We must get a time limit exceeded error. Yeah, we got time limit exceeded error. I'll explain memorization right now. So you can see here there are many overlapping subproblems. To take care of those overlapping subproblems, we do memorization here. You see 1 comma 1 here, 1 comma 1, 1 comma 1. Again, it's again computing it. We don't need to recompute any values here. So we would just store the overlapping subproblems and store them in a DP matrix. So let's define a matrix here. Let's take sizes from here. Sorry. And then our next column value would be grid of 0 dot length. These are the DP. In the DP array, we're going to store all the subproblems. Now I'll just pass it as an argument here. Now I would write it here too. DP values. Let me zoom in. Yeah. So now we have the DP value as an argument, and we return the row and the column values here. And now here our DP memoization starts. So first let us initialize all our DP values to -1. So it's going from grid.length, and then a second loop is going till this value. Now I would initialize all the DP values to -1. So I and then j is equal to -1. So now we have all our initial values. Now let's finish our helper function with DP values. So if DP of the row and the column, if it's equal to -1, if it's not equal to -1, then we would return that answer. And if at all, we don't have the value, we will declare it here. So let me copy this point. Yeah. So I copied it here, and then it's equal to the grid row column, same thing. And next thing or next column also we'll do the same thing. I'll just copy this whole line and let me paste it here. Okay. And even this is same. Even I'll write the else here. And then DP of row column is equal to grid row. Yeah. The ending, again I would check if the DP row, again this is the same condition we are checking. Let me copy this again. We will return, else we will do the same thing again. Else return is equal to. I will change the arguments in the function calls. I'll add a argument called DP here. Yeah, it's all good. Let me run. Solution cannot be applied. Okay, I forgot to add the DP argument here too. Let's submit the code. This took lesser time. You see, the time complexity is good, 70%. But the space is kind of bad because we have used a DP array here. We can use better optimization ways to tabulation. I'll make a other video on that. So I hope you guys understood it, and thanks a lot. DP is very easy. End of the day, it's all recursion. If you know recursion, you know DP very well. So thank you guys, and please subscribe.